Hello and welcome to my channel. I am the Mad Computer Scientist. I would like to welcome all the new people to my channel who discovered me through the Redeemed Zoomer video. I will do a bit more of that content, but I'd like to let you know I'm not going to do that here. I'm going to do what I intended to do with this channel and cover a computer science topic that's also a math topic, believe it or not. If you are new here, please take a moment to subscribe and ring that notification bell, and if you ring that notification bell, you'll get further updates. Today we're going to discover a programming challenge I found on Project Euler. The programming challenge is to write a function to determine if a power is a power of another number. Fortunately, if you've studied higher level math such as pre-calculus or trigonometry, you probably know there's an easier way to do this. And that's the way to convert logarithms of one base to another. To convert a logarithm of one base to another, you take the higher number and divide it by the number that's the base. Now, while this does work especially well on calculators, it doesn't always work very well on computers. You're probably wondering why it doesn't work very well on computers, and that's because computers don't handle floating point values very well. If you're going to use this method, you probably should import a precision mathematics library such as NumPy. If you do this with a standard Python library, if you divide natural log of 243 by the natural log of 3, you will not get 5 as you expect, but you will get 4.99999 repeating. Something similar happens when you use JavaScript, but it is a different number. If you use NumPy, you will get the expected value. So since we can't do it that way, we're probably going to have to find another way that will work every time. And in the next slide, we're going to go into a shortcut about how to do it if we're looking to see if the number is a power of 2. So what are we going to do if we don't have NumPy available? Well, we could install NumPy. It's just a quick pip install NumPy, or install a JavaScript precision math library using the npm package manager if we're using Node.js. But what we're going to do instead, if we're worried about a power of 2, is use a bitwise arithmetic trick. And we're going to use the bitwise AND. You're just going to have to trust me that this works, but try it for yourself. If you know how bitwise operators work, you can work this out on your own. We're going to take that number, and we're going to AND it with that number minus 1. If the result of this operation is 0, it means that the original number is a power of 2. Note that you can also use XOR to calculate the next highest power of 2, where you take the original number and XOR it with that number minus 1, then you add 1. That should give you the next power of 2. This is faster and more efficient than the division method we're about to show, but as noted, it only works on powers of 2. Now let's talk about that division method. We are going to write our pseudocode soon, but first, before we get around to writing pseudocode, we're going to talk about an edge case that's important here. An edge case just means an unusual circumstance that you want to check for before you check for anything else. The term is not just used in computer science. But the first thing we're going to check in our algorithm is if 2 is passed as our base. If 2 is passed as our base, we're going to use the trick I showed you. If 2 is not passed as our base, we are going to use integer division and modulus division to get the final answer. We want to repeat the integer division until it doesn't result in something that is evenly divided, or it comes back to the original number. Remember, powers are expressed as x cubed equals x times x times x. Thus, if we want to go from x cubed back to x, we take x cubed divided by x and divided by x again. And when we do this, we should come back to x. If the final result of this operation is an integer, it means that x cubed is a power of x. With that out of the way, why don't we get around to writing our pseudocode now? I think I may actually end up writing Python code, but I am not sure. We'll see in the next slide. We are going to start by using some pseudocode that can be easily implemented in Python, and we're going to show the easier way to do the task first. We're going to start by importing NumPy as NP. Then we're going to define the is power function, and we're going to pass the variables x, y into it. Remember that y should be lower. Then we're going to assign the value of 0 to the result variable. Next, we're going to check to see if y equals 2. If y equals 2, we're going to use the bitwise arithmetic trick I mentioned earlier, and we're going to do the operation of x and x minus 1. If that equals 0, we know the number is a power of 2, so we return true. Now, if y doesn't equal 2, we go on to the else statement. We're going to assign the variable of np.log2 of x divided by np.log2 of y to the result variable. Then we're going to check to see if that variable is an integer. If it is an integer, we return true. If not, we return false. But what if for some reason we can't install NumPy? Let's say we have a statistics systems administrator who loves to spell user with the silent L a lot of system administrators like to put in front of it. Well, we're going to use the reliable way, and we're going to assume that x and y are whole numbers and that x is greater than y. We're going to begin by defining the isPower function and pass the variables of x and y to it. Now we're going to use some modulus division to see if x divided by y has a remainder. If it has a remainder, we then return false because we know x is not a power of y. Now, we're going to do two operations repeatedly to see if x is a power. So we're going to take x and do integer division and do x divided by y. And then we're going to take the new value of x and do the modulus operation on that, x mod y. And if that does not equal 0, we return false. Now, this will continue until x equals y. If the loop ends successfully and is not returned, we return true because x is a power of y. This should work for any integer where x and y are greater than 0. For those of you wondering, I did put the last bit in just for the semblance of some mathematical precision with this video because I have been really lax on it in this particular video. But if you're interested in mathematical programming challenges, I recommend you check out Project Euler. It has a lot of them, and I found this one there. Long-time viewers of this channel, and there aren't any because this is a new channel, may know that I like to end these videos with a segment I call Some More Math Fun. And in this case, I was scrolling through Twitter looking for something that would cause a good math argument to get into, because math arguments are so much lower stakes than the political arguments that currently occur on Twitter.com. And I may start calling it X someday, but Elon Musk has to stop doing something first. In this case, we have the two ladies and the old guy pointing meme, I don't know where the cat is. Apparently they're giving us the answers of 6 and 0. If we actually do the math and do it in the correct order of operations, we do 6 times 0 first, and then add 6 plus 6 plus 6. If we do this, we get 18. And as you know, neither 6 nor 0 equals 18. So it seems that whoever created this meme was deliberately trying to troll people as a way to generate obvious clickbait, and in this particular case, they succeeded. If you found this content useful, please leave a comment below. If you have something you would like me to cover, please leave a comment about that. The next video should be about Turing machines and Turing completeness. I'm going to do this because the next video after that, I would like to be similar to the Redeem Zoomer video, where I'm covering someone who insists that DNA is a computer code, and I believe that they may be able to do this if they can show that DNA is Turing complete. I would also have to check to see if someone actually has shown that DNA, by which I mean the molecule itself, and not some man-made system, is Turing complete. Have a good day, everyone.